Alright, today we're going to talk about solving systems with three variables. A lot of times in this chapter we've talked about solving systems with two variables. It's like solving by graphing, solving by substitution, solving by elimination, those type of things. Alright, today we're going to talk about solving systems with three variables now. So we're going to, instead of getting ordered pairs as answers, we're going to get ordered triples. So we're going to get answers that deal with x, y, and z. So here's what we're going to look at. You know how to solve a system of two linear equations and two variables using the elimination method. The same method can be used to solve a system of three linear equations and three variables. So we're going to look at a system of three variables here, and we're going to use the elimination process multiple times. The key is I want to set up equations in order to eliminate a common variable. Now notice in both these equations, what am I eliminating?
Y.
I'm eliminating the y. Why am I eliminating a y? Because then I can get down to a system of two equations with two variables, which is just like what we were doing all of this last chapter.
So are all these, they all have to be eliminated then? They have three.
What?
They all have to be eliminated then?
Yep, we're going to do eliminating. You could do substitution, but substitution is a lot harder.
Yeah.
Elimination is a lot easier. So yeah, we're just going to eliminate and eliminate again.
You only have two variables?
Yep. So we're going to start off with three variables, and we're going to look to eliminate to get down to two variables. And then when I get down to two variables, something like this, I'm going to look to eliminate again. For example, what would I like to eliminate here? I look to eliminate the x's probably, right? So I'd multiply the top equation by -1. So I get negative 3x minus z equals negative 6. 3x plus 5z equals 18. Eliminate my x's. I get 4z equals 12. So z equals 3. Now, I work the problem down to get an answer, and then I start plugging it in to get a second answer. Then I take both of those and plug them in all the way at the top equation, and that's where I get my third answer. So you work the problem all the way down to where you solve for one variable, and then you plug it in, going all the way back up until you get all three variables. Okay? And then my answer here, as I showed, would be an ordered triple, not an ordered pair, because I'm going to have x, y, and z answers. Now, what's the biggest issue with this for most students? It's a lot of work. Okay, and what's the problem with that? If you make a mistake early, you're probably going to get a wrong answer somewhere in there. The biggest mistake I see students make, though, is they write the problem down wrong. And in all honesty, that's the biggest mistake I see students make. And I saw two of them do it today. They copied the problem down wrong out of the book. If you copy the problem down wrong, you probably think you're going to make some mistakes along the way. Yeah, everything's going to be wrong from there on. So make sure you really take your time and show a lot of work on these. Okay, so here's number one. I have x minus 3y plus 3z equals -4. 2x plus 3y minus z equals 15. 4x minus 3y minus z equals 19. Okay, step one, I want to pair the equations to eliminate a variable. If I look through it here, which equation looks like it's the best to eliminate probably? I would look to eliminate the y's. Does everybody agree with that? Does everybody see how my y's are set up pretty well to eliminate? Okay, so I'm going to pair them up. I'm going to take the first two equations first. So I'm going to copy those down over here. X minus 3y plus 3z equals -4. And then I have 2x plus 3y minus z equals 15. Okay, so I paired those two up. And then what can I do? I can eliminate my y. 3x plus 2z equals 11. Is everybody good with what I did there? Pair the first two equations up. Now I need to pair another second set of equations up to eliminate. Well, I'm going to pick the second and the third equation. Does everybody see why I'd want to pick those two? The y's are set up to eliminate already, right? So I'm going to pick those two equations. So 2x plus 3y minus z equals 15. 4x minus 3y minus z equals 19. And which variable can eliminate again here? Anybody? I want to eliminate my y. 6x minus 2z equals 34. Now notice in both of those, I eliminated the same variable. I always want to look to eliminate the same variable. If I don't, that's going to make my second equations tougher. So I've eliminated a variable. From here, I'm down to a system of two variables now. Does this look like something we were doing all of this last chapter? Yeah. So I'm going to write those two problems down here now. So I'm going to take both of these, and I'm going to rewrite them down here. So 3x plus 2z equals 11. Then I have 6x minus 2z equals 34. And which one is set up to eliminate here? I'll eliminate the z's. Add down. 3x plus 6x is 9x. 11 plus 34 is 45. 9x equals 45. Divided by 9. And I get x equals 5. I have an answer now. I have one answer. Now I'm going to start plugging them back in to where I get another answer. So I'm going to take this x equals 5, and I'm going to plug it into one of my secondary equations here. I'm going to pick this one, y(x) is positive. So I plug 5 in for x. Well, that gives me 15 plus 2z equals 11. Subtract 15 over. 2z equals negative 4. Divide by 2. I get z equals negative 2. Now I have two variables. What do you suppose I'm going to do with both those variables now? I'm going to plug them both back into one of the original equations. So I'm going to take both of these, and I'm going to plug it into, I don't know, let's pick the second equation.
You use the same equation here if you want to.
What do you mean?
Like, you just plug in 3x.
I cannot. Why? Because I don't have a y in there, and I need to solve for y. Does that make sense?
Yeah.
So I'm going to just, I kind of go down the ladder, then climb it straight back up. So I'm plugging into that second equation there. So 2 times 5 is 10, plus 3y, plus 2 equals 15. Does everybody see where I get the plus 2? Because it's minus the negative 2. And now I simplify. So I get 3y plus 12 equals 15. Subtract 12. 3y equals 3. Or y equals 1. Now I have all three parts. My answer here is 5, 1, negative 2. Five, 1, negative 2. Okay. Again, throughout this process, can you see that if you make a mistake of multiplying or adding wrong, would that make a big difference? Yeah. Okay, take your time, go slow through these, and show a lot of your work, or almost all your work you want to show, just so you don't make mistakes. Everything we're doing today will always have a whole number integer answer. So we won't have any fractions or decimals. That makes it a little more difficult. All right, let's go on and try number 2 here. So here's number 2. 2x plus y minus z equals 5. 3x minus y plus 2z equals negative 1. And x minus y minus z equals 0. As I look at them here, which variable would you say is set up to eliminate?
Z. No, y.
I would look to eliminate the y's. Does everybody see my y's are set up to eliminate? You can do z's. You'd have to multiply by something though. I look to eliminate y's here. So I'm going to take my first two equations right here. So I have 2x plus y minus z equals 5. And 3x minus y plus 2z equals negative 1. And which variable eliminates there? My y. I get 5x plus z equals 4. Now I'm going to pick another equation, another two equations. Which equation would I pick on this one probably? I already picked the first two. Which other two equations do I want to pick? How about the first and the third? If I look at the first and the third equations, are my y's set up to eliminate again? Does everybody see I have a positive and a negative y? So I'm going to set those two up. So I'd say 2x plus y minus z equals 5.
Which equations are you taking out?
I took the first and the third one here. X minus y minus z equals 0. I took the first and the third because then again my y's are set up to eliminate. I always want to try and eliminate the same variable. So the y's were the best to eliminate, so I'm looking to eliminate the y's twice now. And I add down 3x minus 2z equals 5. So I have my secondary equations here. Now what am I going to do with these two equations? I'm going to bring them down and rewrite them. So I have 5x plus z equals 4. And I have 3x minus 2z equals 5. Now as I look at it here, it's kind of set up for elimination, but it's not. Which one would I have to change in order to eliminate a variable? Multiply the top by what?
2.
Nice job. And I'm going to multiply the top by 2. So that gives me 10x plus 2z equals 8. And then 3x minus 2z equals 5. Now what variable eliminates here? My z eliminates.
Would you multiply by 2?
I multiply the top equation by 2, yep. That way I can get a common z there that I can eliminate. So that gives me 13x equals 13. Divide both sides by 13, I get x equals 1. Solve it from there on your own. Take a couple seconds from here. I would take x and plug it back in to solve for z. Then take x and z and plug it back in for y. So take a couple seconds, try the rest of this on your own. Alright, I'm going to start going through this, how you would solve the rest of it. So I'd take 1 plugged in for x, and that gives me 5 plus z equals 4. Subtract the 5 over, and you get z equals negative 1. Now I would take both of those answers and plug it into one of the original equations. So I'm going to plug it into, I think a bunch of people picked the second one it looked like, is that right? Okay, so I plug that in. So that would give me 3 minus y minus 2 equals negative 1. Which is really then just negative y plus 1 equals negative 1. Subtract the 1 over, negative y equals negative 2. Divide by negative 1, you get y equals 2. Now I write my ordered triple here. 1, 2, negative 1.
Wait, I feel y equals 3 because I plugged it.
Alright, so again, the biggest thing on these is check your math as you're going through. Make sure you're not going to make just a simple little mistake of adding or multiplying wrong. Again, it's not that students can't do this, it's they just make a little mistake early on and they get frustrated. Why? Because you did a lot of work and probably got a wrong answer along the way there. Alright, now we're going to look at number 3 here. As I look at it here, I have x, y, z. Which one is set up to eliminate here? The x, the y, or the z? Which one is the best to set up to eliminate? Which one, Allie? I would look at z. Nice job. Does everybody see z? They're all the same coefficient. 2 are negative, 1's positive. Okay? I'm going to set up the first two to eliminate. So I have 2x minus y plus z equals 4. Then I have x plus 3y minus z equals 11. Now I picked the first two equations, now I need to pick 2 more equations. Which other 2 equations do I pick?
First and top, first bottom.
Yeah, at the top and the bottom one, the first and the third one. So I'm going to write those on top of each other. So 2x minus y plus z equals 4. And 4x plus y minus z equals 14. Finish this out from here on your own. Alright, I'm going to start going through this here slowly. So when I eliminate down here, I eliminate z's, I get 3x plus 2y equals 15. Now the other one, when I went to eliminate z's, I actually eliminate y's too. I get 6x equals 18. Does everybody see why that makes it an easier problem? The y's and z's both eliminated. Right away now, I can solve for x. I get x equals 3. What am I going to do next to x equals 3 then? I plug it in over here and solve for y. So I get 9 plus 2y equals 15. Subtract 9. 2y equals 6. I get y equals 3. Now I have two variables. I'm going to take both of those and plug it back into one of the original ones. I'm going to plug it into the top one. So that gives me 6 minus 3 plus z equals 4. So I get 3 plus z equals 4. Subtract 3. I get z equals 1. Now I get my ordered triple 3, 3, 1. Okay? Again, the biggest thing there is check your math along the way and make sure you show your work. Big on this one. Here's your assignment.